Cloud. Okay, perfect. Welcome to the SEM 101 and Applied Method with SmartPLS session. This normally session is designed to be in person, obviously. Professor Olya is right now in Oxford, UK. He is a professor at Oxford Brookes University. He was kind enough, he was kind enough to agree to do this session for us here in person, but unfortunately, due to some complications with visa regulations, that he couldn't be here today, although he's going to be here on October 5th. So most likely he will travel tomorrow. So instead of just canceling the session, do it on October 5th, which we have a full schedule already for the conference, we decided to do, please come in, yeah. We just started. We decided to do an introduction with him by using Zoom. He already has done this once before for us, for ANE, the Organization Association of North America Higher Education International, so he's used to it. And again, I apologize for him not being here in person, but like I said, what we are going to do, we are going to do another session on October 5th. I don't know which time, but I will look at the schedule and I'll find out who is here. And maybe if you are interested to attend another session while he is here in person, maybe practice. Because I asked him to introduce the introduction to SEM for those of you who may know a little bit more or whatever, but he will assume that you don't know about. Of course, he will assume that you have the basic understanding of statistical techniques in general, but not SEM. So like I said, maybe we will do another 1 hour or 2 hour session on, what is today? Today is Tuesday? So Thursday. We are hoping to do it again, but I will obviously make an announcement through the email, and I will of course tell tomorrow at the keynote session. So without further ado, I would like to leave you with Professor Olya. He's, again, as I said, coming from Oxford, right? You're in Oxford right now?
Yes.
Perfect. Okay. And please, the floor is yours. If you want to ask the attendees to introduce themselves quickly, that would be also maybe good, also helpful for us to maybe, before he starts, can you just tell who you are in your institution country?
My name is Lauren Neal. I'm from Harrisville State University in St. Louis, Missouri, USA.
USA.
I'm Nil. I'm from Izmir, Turkey, from Dokuzeli University.
Sevgi Göksel. I'm from Turkey, from Dokuzeli University.
University also, yes.
My name is Aynur. I'm from Kazakhstan, the University of International Business.
In Almaty.
In Almaty, yes.
Almaty. Yes.
My name is Melissa. I'm from University of Manchester, but originally I'm from Turkey.
Very nice. So she just finished her PhD.
Yes, only last week.
And starting a new job next week. So very, very good. Celebration here for you. Yes.
I'm Jack Wei, come from Taiwan Republic of China. I'm doctorate student.
Doctoral student.
Yes.
In Taipei?
In Taipei National Normal University.
University.
Yes. Technology application and human resource development.
Wonderful.
Yes.
Perfect.
I'm Joanna. I'm from the University of Gdańsk, Faculty of Economics from Poland.
Poland.
The same.
Same institution from Poland.
The
Welcome.
same name.
Yes. Same name?
Yeah, also
Really?
Joanna.
Wow. Okay. Perfect. That's great.
Yeah, thank you.
Professor Olya, maybe you can introduce yourself first, and then the floor is yours.
Yeah, thank you very much. Thank you, Professor Cihan Çupanoglu, for invitation, and thank you for everyone for joining to this session. You are very lucky that you reach there, because many things happen nowadays and it's not easy to get there. Then I think you are very lucky, and I would like to be there with you. But technology facilitates the problems. We can still be connected, and as Professor Cihan Çupanoglu introduced me, I'm Hossein Olya. I'm working for Oxford Brookes University in the Faculty of Business. And I'm also methodology editor of one SSCI journal, Journal of Service Industries. I'm a reviewer of 13 SSCI journals, and also I selected as a top reviewer in the field of business and management. For today, I want to start my presentation on SEM based on our schedule. I want to share my screen with you. Just please confirm that you can see my screen.
Yes, we can.
Yes. Excellent. So we are going to talk about partial least square-based structural equation modeling, that the abbreviation of the PLS SEM. What is our agenda? Our agenda is we have the introduction to SEM. We also talk about the difference between CB-SEM and PL-SEM, which is covariance-based SEM against partial least square SEM. We talk about the application of the SEM, various methodological approach that we can do analysis using PLS-SEM. What is the difference between formative and reflective constructs, and also how we can model our proposed model using PLS. And we talk about some psychometric properties of our model, like reliability, validity, fit validity, and construct validity. And at the end, we talk about more advanced and innovative analytical approach to provide some hints for those who are familiar with this SEM and PLS-SEM, so they know how they can improve themselves by more advanced method. But briefly, I want to provide an explanation on statistical methods, like evolution of the statistical method that we have in the science. Maybe a few decades ago, you do some this analysis, you could do your work published, but day by day, journals and the evaluate team, they ask for more advanced analysis. For example, in the past, and now this is still applicable, we just focus on comparison of the factors or comparison of the phenomena using chi-square and t-test. Well, the difference between chi-square and t-test refers to the type of our data. If you want to compare two groups of the people, or two group of the people, that in terms of the factors, which is nominal, we use chi-square. Like if we want to compare the two nominal variables like male and female, we need to use chi-square. But if you want to compare these two groups using continuous variable, like their satisfaction, that is a scale variable, we can measure it. It's not dichotomous variable or binary variable. So we can use t-test. We also have a family of OVA-related tests like ANOVA, MANOVA, that when we have more than two groups, it's not just men and ladies and gentlemen. We have more groups, like 4 educational level or 5 ethnicities. These are more than 2 groups. If we want to compare different groups which are more than 2, we use OVA-related test. But you know, science is developing. We don't just limit ourselves to compare the factors, to compare the groups in terms of different phenomena. Now we are trying to predict the factors, predict the phenomena using the data that we collected. So we use regression analysis to do prediction, and also we use correlation analysis to find the relationship between the phenomena and factors. The difference between regression and correlation is that for correlation, we just focus on the relationship between 2 factors. We are not going to predict, we are not able to predict, but regression helps us to predict. By using the data of X, we can predict the outcome, which is Y. So even in regression analysis, we have different type of the analysis, like simple linear analysis, logistic analysis, multiple linear analysis, and all that I'm going to explain in next slide. Yeah, this is an old version of regression analysis that usually I think most of you are familiar with SPSS, and you are able to use this analysis like exploratory factor analysis, multiple regression analysis, and path analysis. In these approaches, we ignore the error of our model, because technically the software like SPSS does not provide the facilities, the opportunities to include the errors that actually represented by observed variables. I will explain all these terms in the next slides, then you don't worry about the terms that I'm using. I will explain, I will refer again to them. So exploratory factor analysis, as you can see in this, the left side, the first model, we want to know which item consistently related to factor. In other words, we need to conduct exploratory factor analysis to make sure do we measure this factor correctly using appropriate items. For example, this factor is going to measure by 3 items, y1, y2, y3. We need to conduct an analysis to see whether these factors correctly represent the factors that we want to measure and do prediction analysis. We have multiple regression analysis that we hired several factors like x1, z1, z2, z3 to predict y. These z1, z2, and z3 can be control variables or can be predictors. So we call this as multiple regression. Why? Because we are doing regression several times at once. We also have path analysis. The difference between path analysis and multiple regression is that in multiple regression, all arrows end to the outcome. But in path analysis, you can see X predict Y, Y predict Z, X predict Z. So Z is not the outcome that all arrows end with. You can see X related to Y. So we call this path analysis. It's important for you to know how to report your statistical analysis results by using correct terms. So these are the approach that usually we can perform using SPSS, but in these methods, we are not going to focus on reducing or representing the errors. This is a limitation of past statistical analysis. But hopefully SEM help us to consider error, to measure error, to see the effect of the error in our model and in our measurement results, and also in our model testing results. We have 2 types of error. The random error, which caused by reliability, which caused by random problems that lead to the reliability, related to reliability of the constructs. For example, you randomly did mistake. We have some measures, some indicators to see do you have a tolerable random error using Koromba alpha or composite reliability. These are the criteria that we will explain in later in next slide as well. We have also systematic error. Systematic error refer to the validity of the constructs. It tell us validity of the result of the validity test, tell us to what extent we have systematic errors. This error caused by several problems. It can be using the ambiguous questions. Respondent didn't understand the question very well. Or maybe you used or you misunderstand the scales that you used. Or maybe you are using inappropriate statistical analysis using applications. As I mentioned, SPSS, the previous slide, we wouldn't be able to consider the errors. But in SEM, the softwares that offer us application of the SEM, we could consider error in our analysis. We have two types of the SEM. I will explain the covariance-based SEM, PLS SEM. So what is the other advantage of SEM generally? Using SEM, we are able to deal with complex model. We can consider many factors in our model and investigate the relationship of these factors at once. And we also have both observed variable and non-observed variable or latent variable in our model. In regression analysis using SPSS, you just have observed variable, unobserved variable, latent variable that usually you calculated based on composite score of the items that you measured. So you don't have observed variable in SPSS in regression, or I mean old version of the regression that you use using SPSS. But in SEM, you can easily include both unobserved variable, this blue circle, and observed variable. Why we call it observed variable? Because it's obvious to us. Actually, we use this unobserved variable with this observed variable, these items, these questions. So yellow rectangle are our questions. So these are observed variable. In SPSS, we couldn't use observed variable. We just have to calculate the average of observed variable, then come up with the latent factor or unobserved variable, which is blue, then do analysis, like past analysis that I explained in previous slide. But hopefully, in SEM applications, you can insert both items and factors, or indicators and factors, or constructs. The blue one we call as a factor construct. The yellow one we call as item and indicator, or also observed variable. So as you can see, when you include both unobserved variable and observed variable, you can track where is the error, or in other words, which item specifically represent more error. We have some criteria that I will explain. We have some criteria, some cutoffs that will explain you which one has a problem. You have a problem with this item. You didn't measure this item properly. Another advantage of SEM is that you can include many factors at once, many dependent factors at once, many predictors at once. But in SPSS, if you remember, if you have 2 or 3 dependent variables or outcome variables, you have to redo analysis to see. Or the biggest problem was that first you need to conduct confirmatory factor analysis or exploratory factor analysis to check your measurement model. Then if your measurement model results are satisfactory, then you are allowed to do your regression analysis. So you need to do several analyses to reach the result that you need to report. But in SEM, by one time, you could be able to check your measurement model test and also your proposed structural model test. So, as I mentioned, we have 2 SEM approach, covariance-based SEM and variance-based SEM. Here is the difference between 2 approaches. Based on this criteria that you can see in the left, these are criteria, objective, the distribution assumptions, and the second column represent about the PLS SEM, and the last column in the right side shows the covariance-based modeling. So in the middle, you can focus in the middle column because we are going to focus on PLS SEM, not CB SEM, because PLS SEM is more advanced than CB SEM. But you can see the differences. In terms of the objectives, variance-based modeling is prediction-oriented.
Hussein, can you hear me?
Yes.
A lot of people are taking pictures. Do you mind sharing the slides right after the session?
Sure, yes.
So,
Yes. No problem.
You take pictures, but he will email me and I will email all of you. I'll make sure that you have these slides. And when he does on Thursday again, I hope you can participate and do some of the hands-on activities. Sorry, thank you. Thank you.
No problem. So in PLS-SEM is a prediction-oriented approach because of the type of the analysis. The focus is in the prediction of the outcome by reducing the error. But in covariance-based modeling approach, the focus in reducing error with the focus of the factors. Actually, it aims to reproducing the covariance matrix without focusing on explained variance. As you remember, we are doing regression, we are doing SEM to predict the factors with high level of the accuracy. So PLS SEM is an approach which is prediction oriented. And another difference about distribution assumptions about our data type. In PLS SEM, you could do analysis using non-parametric data, which was the main and serious assumption for CBSEM. Actually, CBSEM, you can rely the result of CBSEM by providing evidence of normality of your data. It means that your data should be normal, then you are allowed to do SEM analysis, which is very difficult nowadays, not just nowadays, because of the context, because of the field that we are working. We are working in social science, which many things are not normal. So it's a very serious assumptions, or let's say problem for us to rely on the result of CBSEM, which requires for the normal distribution of our data. But PLS-SEM help us to do analysis with non-parametric data or non-normal data. Another difference of PLS-SEM and CBSEM refers to the sample size. CBSEM required larger sample size or high number of the respondents. At least 100 to 800 is required to run the model and come up with the accurate results. Although this number are subjective, so you can see in different references that this 100 is sometimes it's 200. Many reviewers believe that less than 200 you are not able to run CBSEM. But PLS-SEM they recommended with the data more than 30 you can run your model. In terms of model complexity, we can draw and propose a large model or complex model. We can hire many factors as dependent or independent factors. But in CBSEM, we have restrictions. We are not able to employ many factors. We can hire factors that including the items less than 50, because if you increase these factors, these items, the error will increase, and it's very difficult to rely on the results. Another difference about the parameter estimated is that PLS-SEM is more flexible, is a potential bias. It means that if you include more factors or more data in your analysis, it considers the error will change based on the number of the factors and the size of your sample. But in CBSEM, it's stables. It's not like PLS-SEM that automatically consider these changes. Another important issue is that they are different in terms of the number of the items or number of the indicators that you are using for measuring each factors. Typically in CBSEM, you need to use 3 or 4 or minimum 2 items or 2 questions to be able to represent your factor. We wouldn't be able to run our model with the factors that measured with one item or one question, which was the case. Many times we measured factors by asking one question or one item. So CBSEM didn't allow us to include the factors with one item or with one question, that measured with one question. But PLS-SEM, we are able to include factors that measured by one item or 2 items. But usually we wrote here 3 or 4 because it's tricky if you just rely on 2. If you come up with a bad validity or inappropriate validity result, then you might have to delete one item, so you will have problem. Then again, you would not be able to run your model, because if you drop one item and you come up with just one single question, so again, CBSEM would not allow you to run your model with one factor, with one item. Another difference is about some assumptions. In CBSEM, we need to adjust many assumptions for testing our models. We need to define the softwares that which type of the analysis we want, and there are many assumptions that must be met. But in SmartPLS, we have some advanced tools like jackknifing or bootstrapping that help us to reduce error by some techniques, by random sampling, by increasing the random sampling within our samples, which increase the accuracy of our estimations. I will explain bootstrapping in the next slide as well. Very important difference between CBSEM and PLSEM is a type of the factors that we can use. Typically, we could use reflective factors in CBSEMs. I will explain what is reflective and formative as well. Don't worry about these terms. But PLSEM help us do analysis with a model that include both formative and reflective indicators. The last difference is about the fitness of the model. CBSEM is more advanced. We could check fit validity of our model with the data, with the empirical data. But PLSEM in the version 2, we wouldn't be able to check fitness of our model. But recently, PLS 3 released and developed that address this issue. Now, using new version of PLS-SEM, we can check fitness of our model with the data, which was a problem in the last version of PLS-SEM. So ignore this none in this table, because using new version of the softwares, you can also test fitness of your model like CBSEM. The last point is about the PLS-SEM is that this approach decreasing the errors for the sake of increasing R square of the outcome. What does it mean, R square? Any contribution? What does it mean, R square? R square shows us what? Yeah, any contribution? Actually, R square actually calculated and reported for the outcome factors, like dependent factors. And it's ranged between 0 to 1. And it tells us to what extent the outcome factors represent and explain by independent variable, by X. In other words, to what extent the change of the outcome will explain by predictive factors. Let me explain to you by example. For example, you are going to measure performance of your company. You hire several factors like creativity, like employee satisfaction, and one more factor, which is pricing strategy, or marketing strategy, marketing practices. So if you come up with, for example, R square equals 0.2, it means that if your performance change 20%, if your performance change, 20% of this change refers to these factors, these three factors, which are creativity, employee satisfaction, and marketing practices. If you increase the number of the predictive factors, we expected, empirically, we expected to increase the number of the value of the R square. For example, if you include one more factor which is very effective, like governance, then your R square would be increased from 0.25 to 0.40. So you can see by increasing the factor, you are able to explain very well your outcome or predict your outcome very well. If you come up with high level of the R square, it means that you selected the factors that will explain the outcome. This is very important because, as we mentioned, we are looking for prediction of the factors. So it's very important to come up with the high level of the R square. And SmartPLS helps us to reduce errors with the focus of increasing R square for the outcome. So we could rely on the prediction results better than CBSEM results. So although there are some other justifications for usage of the PLS-SEM rather than CBSEM, as I mentioned, the functionality of this software in terms of the prediction of the target construct, which is our outcome, is better than CBSEM. You could also run your model, do your analysis with a smaller sample size. You can model a complex version with many factors, many independent factors, many dependent factors, and many mediator or moderator. We don't have serious assumptions and problems for the data analysis, like normality of the data. So it wouldn't be a serious problem for you to run a model with non-parametric data. And also it's advanced in modeling of social science by including both reflective and formative measurements in the model. Another limitation of CBSEM is that you need to provide theoretical support for each single path you draw in the model. It means that for each hypothesis that you are proposing, you need to have a strong theoretical support or strong theory. But those who are using PLS SEM, they claim that you could rely on the result of this analysis, although you don't have a strong theoretical background. Although I'm not agree with this statement, I'm just conveying their view to you. They believe that it's kind of explorative analysis. You can explore the relationship and the effect of the factors on each other. There's no need to have a theoretical support. Based on the theoretical support, you propose your hypothesis. So you could do some explorative analysis. Another advantage is that you could also select binary data like dual factors like men and women in your factors, which was very difficult to rely on the result when you are using CB-SEM. So maybe you are interested in application of the SEM. I listed some most popular softwares for CB-SEM and PLS SEM. CB-SEM, you can run your model using MOS, Lizrel, M+, and all that. This that highlighted in red are most popular software. And PLS SEM, as I mentioned, SmartPLS new version, SmartPLS 3 is just released, I think, a few months ago. And you can use this software for running PLS SEM. Some of these softwares are free, and some of them are required license that you should purchase the license. Yeah, I provided a screen of result of SmartPLS, the outcome. I want to briefly explain what is the main component here. In PLS-SEM, we have two types of the model. We have to talk about two types of the model, which first is a structural model in the inner side, like the blue circles. These are a structural model, or let's say proposed research model that covers your hypothesis. We have measurements model. Measurements model refers to the relationship between your constructs. Construct is factor, is this blue one, and indicators or items or questions, which are yellow rectangles. So measurements model, as its names you understand, it refers to the measurement stage. You measure this factor using these items, these indicators. So we are going to check in measure model stage, do we measure our factors correctly? And here in the structural model, we are going to see the effect of the factors on the outcome, which is usually is our hypothesis testing step as well. So in measurement model, regardless of the type of the factors, we need to make sure about the measurement of all factors. It doesn't matter they are mediator or dependent variable or independent variable. We need to make sure that we measure all factors correctly. But in the structural models, we are interested on the effect of the factors on the outcome. Yeah, here I provide more explanation about the terms that I used in previous slides. And this, you need to get familiar with these terms when you are using a SmartPLS. As I mentioned, these middle rectangles shows you, which include the blue circles. We call this an inner model weight, which is our structural model, which calculate the pass coefficient or regression coefficient. For example, the effect of Y1 on YC, this is a pass coefficient or regression coefficient, which can be our hypothesis. We have a measurement model like the rectangle in the left up that include Y1, that we can understand Y1 measured with 3 items or 3 indicators or 3 questions. But as you can see, we have other terms like exogenous variable and endogenous variable. Exogenous variable like Y1, Y2, these are exogenous variable. Why we call it exogenous variable? Because we don't have other variables that lead to this variable. But if you look at the endogenous variable like Y3, you can see 2 factors lead to this Y3, which is endogenous variable. Again, you can see we have latent variable, and we have observed variable. So these blue circles are latent variable. This is unobserved for us. But this yellow rectangles, these are observed variables. Because we measured, we know what are these questions. Why usually maybe you ask that why we need to know, why we need to have observed variable, why we need to know to have unobserved variable. You know, imagine this Y3 is a performance of your employee. It's very tricky if you go to your employee and ask them, how is your performance? Just with one question. Yeah, they may mention, yes, my performance is high. So what we are going to do, we are going to ask several questions. Cross-check. We call these several questions as observed variable to know more about unobserved variable or latent variable, which can be performance. So when the respondents are looking at the question, maybe they couldn't understand that you are asking about the performance, which is latent variable, which is unobserved variable. But the questions are observed. Yes, another important issues that I must talk here about the reflective factors and formative factors. These are reflective factors that usually we use in CBSEM, but PLS we could also include formative factors. Just look at, for differentiation, look at the direction of the arrows. In reflective factors, the directions start from the latent variables and ends with items, indicators, or observed variables. So it starts from the blue one to yellow. These are reflective factors. But in formative, the indicators form the factors. So look at the directions. You can see the direction is inverse than reflective factors. Yeah, I want to exemplify what is reflective and formative that maybe some of you are not familiar with. Reflective factors, in reflective factors, all of the items, all of the questions that you are using to measure reflective factors must be highly correlated. It means that you need to have all these conditions to measure this factor. For example, if you want to judge about timeliness of one of your employee, you are checking 3 conditions or 3 situations. Is he or she accommodate last-minute requests? Is he punctual in the meeting deadlines? What about the speed of the returning phone calls? So you make judgment based on the performance of your employee based on these three factors. If they are good at three, then you can mention this guy is good in timeliness. But in formative, there is not such requirement that they should be good or they should satisfy all three conditions, three factors. For example, about life stress, if someone want to tell that I have life stress in my life, no need to have different conditions like job loss, divorce, or recent accidents. Any of these factors could lead to the life stress. No need to have all this. So this is a difference between reflective and formative. But just bear on your mind that in reflective, a high correlation is required between the factors, between the indicators. But in formative, there is not such requirement that all these three conditions, all these three items should be highly correlated. But maybe you have a question about the differentiation between reflective and formative, which is not easy. You should have a strong knowledge about the type of the factors that you are going to deal with. So I provided an example for the reflective factor. For example, here is loyalty. We are going to measure loyalty. We measure loyalty using three questions. You can look at the questions. So we could call a loyal to someone, to a customer, to employee, or to tourist that meets all these three conditions. For example, they most likely revisit that destination in next year. Then they should believe that this visit was so highly satisfying that they convince them to repeat it. It's kind of revisiting intention. Or they should recommend this destination to others. If someone rate all these factors together in the same range, then we could call this person, this respondent, as loyal. But in a formative situation, we are going to measure service experience in the airport. You have physical environment, you have interaction with the staff, interaction with customers. No need to have all this to create an enjoyable experience about the service at airport. Any of this condition can lead to a memorable experience for the passengers. So this is a difference between reflective and formative factors. I'm going to again repeat that in the CBSEM, we could just use reflective factors, not formative factors. But SmartPLS or PLS-SEM, we are able to have both in our model. So we can generate more knowledge. As I mentioned in analysis, we need to focus on two types of model testing. The first important is measurement model testing. The second one is structural model testing. First, you should provide evidence of the measure model testing by providing some criteria which are satisfied, like reliability and validity. If you provide evidence of the reliability and validity of your measurement, then you are allowed to do structural cohesion modeling tests. In other words, then you are able to test your proposed hypothesis. So what are these measurement model criteria? We generally have two types of criteria. First, reliability. Second, validity. And reliability is has a first priority than validity. It means that first you need to check reliability of your measures. Second, if it's okay, then you can go and check validity. Because if you remember, reliability tell us about random error, and validity tell us about systematic error. Then reliability means that you can rely your measures. If you repeat this analysis, this research with the same respondents, you expected the same result, because in any analysis, any experiment, you have some random error. So random error can be tolerated to some extent. So, but systematic error is very difficult. Then the first you need to check reliability using composite reliability or Corumba alpha reliability. One of these can be reported for checking internal consistency of the reliability. The cutoff for both of them are 0.7. Some of the researchers believe that 0.6 also acceptable for the exploratory research. Another reliability refers to indicators reliability. That we can measure indicator reliability by checking factor loading. I have examples for this in the next slides. About the first, after checking the reliability, then you can go and check your validity or construct validity, which include two types of validity: convergent validity and discriminate validity. Convergent validity means that to what extent your factors convergently are related to explain a construct, to explain the factors. But discriminate validity refers to the factor, the items of the one factors, the relation of the item of for one factors with the item of the relations of the item for other factors. In other words, the questions, the items that you use for specific factors should be underlined on that specific factors. You should not have conflation between the item of the one factor with another factor. They should be discriminated. For example, if you want to measure satisfaction, you, by using three questions, these three questions should be underlined and related to the satisfaction. It should not be appeared for the performance. So if you, for example, one of the items for satisfaction come and underline under the performance, it means that you have a problem of discriminate validity. Your measurement are not able to measure correctly the items related to each respective factors. We have, for the convergent validity, we have one test or one criteria, average variance extracted. We call it AVE, which would be greater than 0.5. Don't worry, guys. These indicators all can be calculated by the softwares. So just you need to know the type of the test, the type of the criteria. Then you should know the cutoff that I provided for you, so you can easily check your results. Software calculate all this for you. And discriminate validity, we have several approaches. You can just check each of them to provide evidence of the discriminate validity. For example, you can use the result of the Fortner-Lerker criterion, or cross-loading, or HTMT criteria that I will explain. I will provide an example for you. But just don't remember, first you need to check reliability, then validity. If the results are satisfactory, then you can go to check, you can go for the testing of your hypothesis. As I mentioned, one of the approach for checking discriminant validity is cross-loading. I provided one example for you. For example, if you look at this column, the first column, we use 3 attractions questions to measure the attraction. In other words, we use 3 items that measure attraction of a place. So this value should be greater than 0.5. These factors should be greater than 0.5. This is the criteria. And another criteria for the discriminant validity is that the magnitude of this value, for example, attraction 1, which load under attraction, the main factors, this magnitude of this value should be higher than any other value on that specific row. So in other words, these questions used for measurement of the attraction, not other factor, not like corporate social responsibility, not like competitiveness. If, for example, the value of the attracts 1 was more than this number 0.75, it means that we really fail to measure attraction, because this item represents competitiveness, not attraction. But in this result, you can see the used measurements will represent the factors that we try to measure. All of the factors loaded more than 0.5, and the items value of the loading for each item underlined on the respective component is more than the other factor loading for other factors. But I provided a screenshot of the software to explain provide more explanation for you. For example, these numbers are these values you can see in the left side, like 0.84, 0.78. These are loading value for a standardized factor loading. This standardized factor loading should be more than 0.5. For example, here you have 1, which is related to 1 question for the service. You can see 0.47. It means that you have a problem with the validity of this factor. You might have to delete this item. But many researchers don't delete because they believe that this will lead to the loss of the informations. But if this value is very low, you have to delete it because you need to provide evidence of validity of your measurements. Apart from the cross-loading, we have 2 other approaches for checking discriminant validity. As I mentioned, any of these approach you use is sufficient for 1 article. On the left side, I provided a screenshot of a SmartPLS report about Fortner-Laker criteria. In this criteria that proposed by Fortner and Laker, you need to provide the evidence that the square root of the average variance extracted for each construct, this that you can see in diagonal, 0.717, 0.659, this should be higher than its highest correlation with any other constructs. These numbers are correlation. This is the correlation between this factor, this factor, this factor, and this factor. This, as you can see, 0.71 is higher than any other correlations. And 0.65 is higher than 0.56 and 0.34. So we can see we have a discriminant validity in our measurement results. Another approach for checking discriminant validity, which is relatively new, is HTMT, which stands for heterogeneity monetary ratio. What is the criteria for this one? HTMT value should be less than 1. If you look at the outcomes, the results, you can see for all pair construct, this factor is less than 1. So we can claim that our measurement is valid. Now we are allowed to go and check our structural model for testing our hypothesis. But what is important in testing the models with the which include formative factors? If you remember, I mentioned in formative factors, no need to have a high correlation between the factors. You remember about the life stress. Don't need someone to have divorce or accident, all of them together. So no need to have a high correlation between these factors to measure outcome, which is life stress. So this refers to the collinearity issues or multi-collinearity issues. The formative measurement model, we should not have a high level of the multi-collinearity issues between our factors, among our factors. So how we can check multicollinearity? Using VIF, which stands for variance inflation factors. Variance inflation factors should be less than 3 for each pair constructs. So although the cutoff are different, as I mentioned, so it depends the type of the context of your study, the type of the data you are using. Some researchers accept 5. Some researchers believe that even less than 10 also is acceptable. But if we want to be a little bit conservative, we can recommend strongly that VIF for formative measurement should be VIF should be less than 3. And another important factor in measurement of the formative factors is that these indicators should be highly related to the construct, and this relationship should be significance. For the checking of the significance, we have 2 options. We can look at p-value, which should be less than 0.5, or we can look at t-value, which could be more than 1.6 or more than 1.9. It depends to the level of confidence that you are looking for. Yeah, empirically, we could say that the estimated value of the outer weights is informative measurements models are frequently smaller than of the reflective indicator. This is a difference between reflective and formative. I hope to come to join you. Yeah.
Quickly, sorry. Just want to tell you, whenever it's a good time for maybe 10-minute break, let me know.
Okay, if you want, we can do it. I need to.
Okay, okay. Let's do it because it's been 1 hour now. You
Okay.
need to take a break. You've been talking quite a bit, and our attendees here will get a nice coffee. Espresso is ready there, and then they will come back. Is it okay if we meet back in 10 minutes?
Yeah, enjoy.
Perfect. Thank you. Thank you so much. Yeah. Go get it.
15 minutes later.
Okay, 15 minutes later.
Okay.
I said 10, but he said 15. That means he needs 15 minutes. We'll do it. Thank you. We'll
Okay,
see you.
enjoy. See you
Yeah.
then.
We'll just keep the session alive. Okay, don't kill it, please.
Okay.
Okay,
No
perfect. Perfect, perfect. Thank you. Hussein, there is one question.
Yes.
If SEM, SmartPLS, can be used in economy research, econometry, economy.
Yeah.
So there is a question from the audience, is that if this method, PLS, SEM, can be used in economy research, where it's not like for example, satisfaction like you are describing here, but the dependent variable is something, let's say, productivity of a country or something. Have you ever seen?
Yes, yes. You know, then you will measure productivity using one single item, I think you can use SmartPLS
Okay.
by using.
Perfect.
Yeah.
And when you come here, maybe we can talk some examples in that context too. So please continue while you state, and then after that, if you have any questions, and of course, when you come on 5th, which I will tell you the time, we will determine that together, and then you can take questions in person too.
Oh, sure. Thank you very much. Hope everyone enjoyed the break and coffee. Let's continue. We talk about the PLS SEM structural model evaluation, as we claim that this smart PLS deal with non-parametric data. How we can claim this by even we are at the same time we are telling that this method can cover a small sample. As you know, by increasing the sample size, we could claim that we have normal data, so we can use parametric analysis. But how we can justify that by low sample size, we can do non-parametric analysis? So they address this issue by a technique that named bootstrapping analysis or bootstrapping techniques. What is this techniques? These techniques create several, like 1,000 or 100 samples, subsamples from original sample with replacement randomly. So it means that you have, for example, 100 cases. Bootstrapping come and select different samples within original samples several times. So then we can interpret this, we are increasing our sample size. When we increase our sample size, then we can mention we address non-parametric issues or non-parametric assumptions. So by using bootstrapping techniques, they address this problem of normality of the data and these assumptions that the data should be parametric. So I want to just review the explanation that we had in previous slides. As you can see, these results in that show the connection between blue circles with the yellow rectangles refers to our measurement results. The values that shows the relationship or the effects between the blue circles shows the result of our structural models or your hypothesis. And also, usually we need to report R-square for endogenous variables like these factors that I mentioned, endogenous variables. We try to come up with the high value for R-square, which explain to what extent this outcome explained by these indicators. The last point is about the exogenous latent variable and endogenous latent variables. As you can see, I put it here, exogenous variable, competition is exogenous variable, like is exogenous variables, causality is endogenous variable, and clustering is endogenous variable. So we have two endogenous variable and two exogenous variable in the left. Then you can know what is the endogenous and exogenous variables. The good news is that using a SmartPLS, you can have both reflective factors and formative factors at the same time in your model. If you look at this model, you can see that ITUs, commitment, trusts, and share are reflective factors, but this performance is a formative. So as you can see, you can employ different type of the factors in your model. So you have more flexibility to apply different type of the factors for your testing your structural model. I also provided different type of the models that you can use using a SmartPLS. For example, if you look at the left and top model, you can see it represents a reflective and reflective type. Why reflective? Reflective because if you look at the arrow, is start from the latent variable to indicator variable. And also, if you look at this outcome, you can see it start from the hook, which is outcome, to the independent variables. But in contrast, if you look at the reflective and formative type, you can see although these three independent variables are reflective, but they form hook, which is our outcome variable. So we call this as a reflective, and right side is formative. Reflective formative type. You could also take a model which is formative reflective type. As you can see, the arrows start from indicators X1 to LOC1. So we call this as a formative. Then the left side, all independent variables are formative. And the right side, which is our indicator, you can see it start from the hook to LOC1, LOC2, LOC3, which is reflective. So this is a formative reflective type. Another type of the model is formative formative. You see the all ends, these indicators ends to the latent factor, and these three independent latent variables ends with hook. Then all direction of the path end to the latent variable. We could also do moderation analysis and mediation analysis. In this session, I just want to explain a little bit about the moderation and mediation, what we are targeting by testing mediation analysis, and what is moderation analysis. Briefly, I'm going to explain and take an example. For mediation, why we need mediation? We need mediation when we believe that our independent variable are not able to explain the outcome directly. We believe that something is in the middle. For example, if we want to predict depression among our employee, by using stress and self-esteem, we believe that these two indicators, these two factors, are not able to directly predict depression for us. Based on the theoretical background, based on your literature review, you will understand that stress and self-esteem are not related directly to depression. They could predict depression through anxiety. In other words, stress and self-esteem predict anxiety or affect anxiety, that this anxiety lead to high level of the depression. So we have one factor in the middle that facilitate the effect of the stress and self-esteem on depression. So I want to example in our case. For example, Professor Hossein Olya is a mediator. I couldn't connect and speak with you without Professor Hossein. I connect Professor Hossein, then Professor Hossein connect to you. Now we are connected together. So Professor Hossein is a mediator. Professor, am I allowed to take you as an example? Are you happy? Is he here?
Yeah. I'm here. I'm a connector. Very, very.
So moderation test has another philosophy. In moderation analysis, we don't believe that a factor is in the middle, that without that factor, we couldn't reach that outcome. In the moderation, we believe that there are some factors that moderate the relationship between independent factors and dependent factors. They are not intervening, they are moderating the effect. For example, again about the depression, we are going to test the effect of the stress on depression. it's clear that high level of the stress lead to the high level of the depression. But what about the conditions that we have a social support? If we have a social support, we could moderate this effect. We can decrease or increase this effect. So the in moderation, we are going to test the moderation role of the factors. We are going to test whether if we have a social support in our society for the individuals, the level of the effect of the stress will decrease the depression. So social support is not going to be mediator, but it's going to moderate the effect. It's going to decrease the effect. So all this analysis can be performed by using SmartPLS, and I hope to join you in 5th of October to do some practices and see how we can do this analysis using SmartPLS, which is recently gets high attention. As you can see, nowadays in 2015 is more than 4,000 articles, and probably in 2017 it reached to the 5,000 articles that they use this advanced technical approach, analytical approach. If you want to have a critical view about the SEM, and also what are the advantage of the PLS SEM over covariance-based SEM, you can check this article that written by Nicole et al. In 2016. You can use it as a reference as well. But we believe that, as a review, we believe that Smart PLS SEM help us to deal with data with low sample size. We could model complex phenomena by hiring many factors. We could improve the ability of the model, the ability of the prediction of the model, I mean predictive ability of the model, by using these softwares, by focusing on increasing the R-square value. You can claim that you are improving the predictive ability of your model. Then you can rely on the result of the predictive model. Then, based on the using bootstrapping, no need to have a concern about normality issues. By bootstrapping, you can generate many samples, many random samples, which extracted from original samples. So to some extent, we can say that you increase your sample. By increasing the sample, you are reaching to a normal population or normal data distribution. So you can address the serious concern of this assumption, which is data normality. Another issue that addressed by PLS is you can also include formative factors and also items that measured by single value, like economical factors that you are targeting. And also, although I personally don't agree with the last point, but this claim that it also supports weak theoretical background or justification for proposed structural model. And you can refer more references I provided here that talk about the limitations and implications for addressing these limitations. At the last slide, I want to share the latest approach in tourism and service research that is it advanced both theory and method. I mean that I'm going to introduce you some analytical approach that are not just a tool for analysis. They are analytical approach that they are able to generate new knowledge. using SEM that we discussed till now, we are able to investigate the net effect of the factors on the outcome, either formative or reflective. For example, in the case of restaurant, what make our customers satisfied? If in SEM we can, based on our data, we can understand high quality of food and low level of the price could lead to high level of the satisfaction. Yes, this is helpful, and we need to know the net effect of each factor on the outcome that we can understand, we can analyze using SEM, either SmartPLS or CBSEM. But what about the combination of the factors? If we combine these factors, then what will happen? You know why we are arguing this important issue? Because we are dealing with this human phenomena. The phenomena that humans are decision makers is complex. Always people consider factors, consider criteria together, not separately, not SEM. In SEM, just we are looking at the distinct effect of each factor. But in FSQCA, which stands for fuzzy set qualitative comparative analysis, we can find how we can combine the factors together to predict the outcome. So we need to know what combination of the factors lead to our satisfaction as outcome or the performance as outcome. Using SEM and FSQCA, we could understand about the sufficient antecedent factor and sufficient configurations. Still, we didn't know what factors are necessary. What does it mean necessary? Necessary means that without this factor, we would not have that outcome. So we need to one more analysis, which is necessary condition analysis. Using necessary condition analysis, you can identify necessary factor for your outcome. So for example, in our case, quality is a necessary factor for satisfaction. Maybe price is not necessary, but quality is very important, is critical. So as I mentioned, you need to employ different type of the analysis to explore different perspective about your complex phenomena. Why complex phenomena? Because the issues that we are dealing, we are working, we are doing research are not straightforward. It's not like engineer that they just you consider 1-2 factors separately, then you reach to the outcome. In social science, most of the phenomena are complex. We have many internal and external factors that we should have a look as a comprehensive view. So FSQCA and NCA help us to deepen on our understanding about complex phenomena. You can run FSQCA using FSQA software. The name of the analysis is the name of the software as well. And NCA also can be run using FSQCA, which is the free source software. And also you can use our software for running this advanced analytical approach. So it's just the beginning, as I mentioned. Every day new methodological approach are proposing, and we need to learn. It's not like before that just using regression analysis or just CBSEM, we could publish our work in the top tier journals. We need to learn new approach that actually they they both facilitate our work, and they also provide new insight to the phenomena that we are doing research about. At the end, I want to recommend you to consider the Service Industry Journal, which is the first peer review journal in the service industry. I'm methodology editor, and we have a specific platform in these journals for the PhD students and for those researchers that they are providing new methodological approach in their research. The name of the journal is Service Industries Journal. If you have any question, I would be happy to reply.
And the editor of this journal is also our keynote speaker.
Yes, editor of this journal is Professor Altinay. He is also the keynote speaker of this conference. Thanks to
yes, right. And hopefully also Hussein will be here tomorrow. We are working on tomorrow, right?
Yes.
For you to come, yeah, tomorrow, and then on the 5th, Thursday, we're going to have a session with him. Any questions so far? I know this is not the same like face-to-face, but hopefully we are going to cover this. Any questions for him at this time? Yeah, please.
Thank you for your presentation.
Welcome.
My question is about qualitative research methods combination with the quantitative research methods about the data collection and data analysis. What do you think about that? Because we are always researching in the social sciences and more qualitative, maybe the qualitative methods, I believe, in my opinion, help us to have a more different data. And do you think that it is good to combine them, or use of the PLS SEM will be enough to collect the data and make an analysis?
Yeah, thank you for this informative question. As you correctly mentioned, combination of both qualitative and quantitative analysis is highly recommended. Even if you want to publish in top-tier journals, they are seeking to see those articles that include both qualitative and quantitative analysis. Because as you mentioned, using quantitative analysis, we could just investigate some objectives. We are not able to explore new things. In social science, some issues are very complex that we need to have a deep understanding that can be explored by qualitative analysis. But how we can have two type of the analysis in our articles? I have two recommendations. The first one is that for those who just know quantitative analysis, and it's difficult for them to include qualitative analysis, the easiest way and effective way is that to include 2 or 3 open-ended questions at the end of their survey questionnaire about implications, about the limitations, about the problems that the responders have to address. So if you have open-ended questions, and kindly ask them to write their view in detail about those issues, then in your article you can claim that more explorative research, more qualitative research were required to understand about those limitations, those problems, those issues, that we include these 2 questions at the end of our survey. So then you can claim that you did you combine qualitative and quantitative approach, which is, I think it's very easy and very effective. You can easily justify this issue. Another recommendation is that you could also hire new analytical approach. Although you collected your data based on a questionnaire survey, you come up with the quantitative data, but using innovative analytical approach, you could do qualitative analysis. Then you can mention, we address the limitation of the quantitative analysis by doing qualitative analysis, like qualitative comparative analysis, like FSQCA. FSQCA is a bridge between qualitative and quantitative. Why we claim? Because it explored the combination of the factors that you measured in a quantitative way. So two approach. First, you can include open-ended question at the end of your survey. Second, you can hire and perform a very advanced and pragmatic approach, analytical approach like FSQCA and NCA.
Thank you.
You are most welcome.
Thank you. Any other questions?
Just do we have the presentation?
Yeah. You will email me the presentation. I will email you the presentation. I will put on the website for all of you to download this. Any other questions before we call it a day? Also, I want to let you know that we have a competition among our attendees. Whoever tagged GLOSERV 2017 the most at the end will receive $250 cash prize. So the more you will in Facebook, Twitter, LinkedIn, whatever.
It is in the
Which is not. He's not. And me, I'm not going to pay money to myself. Well, I'll do a lot. But if anybody.
What's the password for the meeting?
It's actually here. The password for the meeting is here. You can just look in there. Professor Olya, thank you so much for your session.
Hope to join you. See you then.
Yep, we'll see you on Thursday. Hopefully tomorrow.
Thank you very much. Have a great day. Bye-bye.
Thank you. Yep, bye-bye.